Hello and welcome. In this episode, I'm showing to you how to blink the blue LED, the built-in LED inside the ESP826601. So this is the ESP01. It's the AI Thinker module. And here we see the blue LED, the built-in LED connected to the transmit pin of this module. So we can blink it to check its operation and to see that we are connecting everything correctly. Then after we can build another projects. That's the same thing you do when you buy a new Arduino module. You just learn how to make the Hello World application, the Blink LED. So if you didn't yet subscribe, please subscribe to this channel to get the new videos. So let's see the connection in detail and know how to write the code. Let's see here. We connect the ESP pins. I leave in the description the full connection to this circuit. We connect the VCC and ground to VCC and ground of this USB to serial module, and the receive in this module to transmit in this module, and the transmit to receive, and two other pins you need to connect. These are first the GPIO 0, this one inside the ESP01, GPIO 0, you connect it to the ground to enter the programming mode. And this is also used in the firmware flashing mode. We'll see it in another video. So you connect it to the ground. This pin is ground. And you connect this pin. It's called the chip enable. You connect it to VCC right here in the USB to serial converter module. That's the connection. Let's see the circuit diagram in detail. Then we see the code. And then we see the operation of the circuit. Here's the circuit we use to program the ESP826601 module. Using the USB to serial converter, we connect transmit in the ESP module to receive in the USB module. We connect the receive in the ESP module to the transmit on the USB module. We connect the ground in the ESP to the ground of the USB module. We connect also the VCC to the VCC 3.3 volt, and we connect the chip enable pin on the ESP module to 3.3 volt, the USB module. And finally, we connect the GPIO 0 to ground to enter the firmware update mode or the programming mode, as we see here. So let's see the programming and the code. Here we choose from tools from menu. We choose the board, generic ESP module. We choose the port, the COM port. We also choose the built-in LED. We choose number 1. This option defines the variable of which pin, GPIO pin, connected to the built-in LED. Here in ESP01, the built-in LED is connected to GPIO number 1, so we choose 1. And then we go to File, Examples. Under Examples for generic ESP8266 module, we choose ESP8266. Then go to Blink, just as we choose the Blink example for any Arduino board, for example, Arduino Uno. Then we open the Blink sketch. Here, after we open the Blink sketch example, we note some stuff that he writes, that he uses the LED built-in variable to find the pin to which connected to the internal blue LED. Then we see that here he uses the pin mode, LED built in as output in the code. Then we note another thing, that the ESP logic is inverted. Then as we use the digital write low, the LED is turned on, and we use the high, the LED is turned off. Then we put the delay 1 second and 2 seconds. Then we press upload and wait for the sketch to be uploaded, compiling and uploading. The percentage is counting. Done uploading. And here now we have programmed the module, and we connected to the operation circuit to see the LED blinking as we see 1 second on and 2 seconds off. Here is the connection. It's the same connection, VCC to VCC and ground to ground. Of course, this module is operated by 3.3 volt. So if you have here a built-in USB to serial converter, built-in 3.3 volt output, you choose the 3.3, or you choose a voltage regulator to power the ESP, or a voltage divider using resistors and another pins. This is the chip enable. You still connected to VCC, and this one is removed. This is the chip. This is the GPIO 0. It's not connected to ground to make the ESP module work in the operation mode. That's all about the circuit of the LED blinking of the built-in LED in the ESP8266. So if you like this video, please like, share and subscribe. Thank you for your support, and goodbye.